Thank you for joining us. I'm looking forward to a great discussion on energy, technology, and innovation policy. I'm Coral Davenport. I cover energy, environment, and climate policy at the National Journal. I'd like to start and have our panelists introduce themselves, starting on the right with Clark Miller. Before we get into our discussion, just wanted to say you've probably seen this in the other panels this afternoon. When we get to Q&A, we will not be doing mics in the audience. We'll be doing questions directly up here. So if you have questions during the discussion, please email or tweet them or text them in, and the directions are there. So we'll start questions. We'll start audience questions with about 20 minutes left. So feel free to send your questions all the way through the discussion. If you think of a question, just send it in, and then they'll be stacked up and ready to go. Panelists, if you could introduce yourselves.
Clark Miller. I'm the Associate Director of the Consortium for Science, Policy, and Outcomes, which is a science and technology policy research center and think tank at Arizona State University.
I'm Erick Lutt. I'm a policy manager at the Biotechnology Industry Organization within the Industrial and Environmental section.
Arshad Mansoor. I'm the Senior Vice President at Electric Power Research Institute.
So the question that we want to answer, the question that we want to explore is, will the newest energy technologies fit into current policy framework, or do frameworks need to adapt? And Clark, I'd like to start with you. If you could give us a lay of the land on current energy technology frameworks, or what's in play now.
So thanks, Coral. As I was prepping for this panel, I ran across a quote about Cape Wind. Acquiring the full array of government permits and sign-offs, a Byzantine process involving dozens of sometimes overlapping, often contradictory agencies, hundreds of officials, and thousands of pages of impact statements, took over a decade. And more than a dozen lawsuits have cited everything from potential disruption of whale and bird migrations to interference with airplane and shipping traffic, the wrecking of commercial fishing grounds, and the desecration of sacred Native American sites, all of which have thrown sand in the project's gears at every turn. And I think that represents sort of what I think a number of us think about energy policy and the landscape at the moment. It's an overlapping, I call it a policy thicket of jurisdictions and arenas. We heard earlier today that we don't have a single national energy, not only a plan, but even an administrator. We heard in the last panel, we have 50 state regulatory regulatory frameworks in the electricity sector. All of that means that, frankly, we need to be putting as much energy and attention and resources into thinking about policy innovation, because technology innovation and policy innovation go together. If you look at the PV sector in Arizona, where I live at the moment, PV sector is dealing with dozens of federal agencies. They're dealing with a half a dozen state agencies and different state regulatory frameworks. They're dealing with local governments and county governments. They're dealing with private sector policies across the different utilities within the state. So you have a very difficult landscape within which to operate and within which to innovate. And so we really need to be putting a focus on building new and innovative policy frameworks. If you think just about PV, in the state of Arizona, we actually have 5 different PV technologies. And I don't mean like silicon versus thin film, right? I mean that we have 5 different social, economic, and policy arrangements that fit around PV to create very different things that inhabit the landscape. So there's rooftop for households, there's big box retailers that have big flat roofs. We have public schools and other public institutions that now have solar, thanks to the Recovery Act, the American Recovery Act. We have utility scale solar, and we have community solar, which is a different model yet again. And each of those things is different, and each of them is supported by a different policy framework that's been established by one or another mix of some of those agencies. So it's quite a complicated space, but it's one in which it is possible to innovate and do innovative things, and I think it's worth putting the time and energy into thinking about how we do that and into training people to be energy policy innovators. We should think about the policy space not as a barrier, really, but as an opportunity, a similar opportunity to be innovative.
You've talked also about this idea, you know, there's this thicket of policies out there, they're overlapping, sometimes they get in each other's way. I wonder if you could point to, and anyone on the panel, please jump in, a couple of examples, whether at the federal or state level, of policies that have been most effective in advancing energy technology innovation. I mean, we've got this field where there's a lot of really interesting innovations going on in energy technology. Are there a couple of spaces, you know, a state or federal example of something that has worked, that has been effective?
If you look at, I will talk from a technology point of view, because that's where at the end of the day, technology will win, and policy will come to help the technology to win if it provides electricity that's reliable, safe, affordable, and clean. So you got to use that metrics. We have 1,000 gigawatt of installed capacity, 1,000 gigawatt, large number. 3 years ago, we were 20% coal, 20% gas, and 50% coal. Just a couple of months ago, we reached parity. A country of our size, changing our portfolio mix on a dime didn't happen just because we had a lot of policy construct. It happened because shale gas was abundant. We figured out how to get it out. We still have to learn how to make it, get it out in the right way. And technology moved forward. I mean, if you look at what you have and what I have, these technologies, it did something for the consumer, so we embraced it. We went from 0 smartphone to 800 million smartphone because it gave us something that we didn't have. I think on the electricity sector, the technology first, and as technologies, that's our dream. We can get the cost down, we can make it reliable, we can make it affordable. And when we do that, policy will move forward with it.
From Bio's perspective, the renewable fuel standard has been very helpful in driving both the first and second generation of biofuels, you know, despite all the political controversy that surrounds it. You know, when they wrote RFS2 in 2007, there was no cellulosic or advanced gallons on the marketplace, and you know, everybody keeps saying that they're not coming, but within 5 years, through you know, the first 3 years being all the rulemaking process, we are now on the cusp of having cellulosic gallons come onto the marketplace here. And it's bringing in foreign investment, it's bringing in private investment. You have companies like DuPont that have put $1 billion into this. You have INEOS that's out of Switzerland. They've opened up one of the first commercial plants in Florida. And you know, that there is an example of the policy that's helped drive these newer fuels and technologies and making them a reality here.
What about on the other side? You know, Arshad, you talked about how there's this space where, in many ways, technology is advancing on its own in the private sector. Fracking technology is certainly an example of that. Are there spaces where technology has outstripped the current policy framework, and the policy has hindered it? You know, the existing policy has hindered or stood in the way, or you know, was designed for a different kind of energy policy. Are there examples where current energy policy is getting in the way? Well,
it's just quick 2 examples. At the last session we talked about grid resiliency. Those of you who are from Northeast, Sandy is in your memory. And if you look at a Sandy-like event, I think one of the things that's clear, that customers are no longer patient enough to be without power for 13 days, 14 days. So they want power to be restored. And I don't know what the pain threshold is, but it's not 13, 14 days. So what is one technology we can do to make that happen, besides taking the whole New York State and making it up 16 feet so that the floodwater will not come? Floodwater is going to come. It may be 17 feet next time. But one is damage assessment. You got millions of miles. When you look at this storm like Katrina, if you look at a storm like Sandy, the damage is widespread. Imagine there were 6,000 trucks that were ready to do damage assessment. If you can speed up the damage assessment, so you know what part of your system was damaged. And the trucks that come in, let's say they have an iPad and it exactly tells them what infrastructure they need to go to, what spare parts they need. You can speed up the process. How do you do damage assessment? All the trees are down. How do you send crews out there? I'm not going to use the word drone. It has a different connotation in this city. But I'm going to use remote control airplanes. We are working with actually universities. We are working with utilities. And imagine the crews have a remote control airplane. It is not rocket science. It's available today. Imagine you go to a place and you fly out that plane at a low altitude and you take the video feed and you integrate with your GIS system and you do damage assessment. And we're working on that right now. I mean, there are still bugs to iron out on integration. But one policy challenge that will pose is actually not public utility commissions or FERC or NERC. It's the policy of FAA. You cannot fly unmanned aerial vehicle for public purpose. So we got to work with FAA, and we are, to change that policy. There's another policy construct, it's privacy policy. If you have an unmanned aerial vehicle that's hovering over your house, who owns that picture of that house? Because your house is straight line with the distribution lines. So that's a clear example of technology like sensors and data and computation will allow us to do damage assessment much more quickly. And if you ask any customers whether they want real-time price or whether they want to be assured that a storm will not knock them off for 14 days, I think the answer will be very clear. So that's a great example of technology moving forward. But I think policy will come in. As a technologist, I believe if we can get the technology right, at some point technology will have to win on its own merit. Is it making electricity more affordable? It is making electricity more reliable. Is it making electricity clean?
I want to first correct one misperception, and that is that the technology happens by itself. We're sitting at a conference sponsored by ARPA-E, which is investing, along with DOE and DoD more broadly, substantial amounts of money in technology. Fracking technology didn't just happen. The government, your government, played a role in the innovation in hydraulic fracturing technology. Moreover, if somebody by the name of Dick Cheney hadn't made a certain set of decisions early on in the Bush administration to create an exemption for gas well drillers around a certain set of environmental regulations that are on the books that they do not have to apply to, you wouldn't have had the boom in natural gas that we've had in the United States. So technology by itself doesn't just happen, right? In the U.S., the technology innovation sector is one that's through and through with policy. So that's an important sort of piece to understand, and it's important in a facilitative role, as well as, I think you're right, a role at times that restricts certain kinds of technology from being adopted. It's very clear, for example, if you look at the history of nuclear power in the United States, we have built one kind of reactor. It was the very first kind of reactor we ever built for commercial purposes and actually for military purposes. And we've built every reactor using the same design subsequently. Trying to get a new reactor design approved for regulatory approval in the United States would be an enormous headache. And that decision has created a situation where we haven't built a new nuclear reactor in the United States in about 30 years. Now, I'm not a huge proponent of building new nuclear reactors. I'm just pointing out that that's a space where policy has had a huge impact. And I would say the failure to create innovative policy that can actually solve the problems, if possible, that the public has set out for the public sector and the private sector together to try to figure out. We haven't figured out how to do that yet. That is to actually convince the public that they should accept nuclear power as a significant piece of the U.S. energy portfolio going forward. So, there are real challenges and real opportunities here for innovative thinkers.
Just fully agree. I think policy and all the other things surrounding technology is an enabler. At the end, technology will win because the performance is superior. At the end, this technology won and landline went away or is going away. 70% of us don't have a landline because it provides superior performance. So enabling it, getting it up to speed, getting it to a place where it will be competitive, absolutely. Policy, innovation, R&D, the national labs, EPRI, Electric Power Research Institute, is vital. But we have to think about technology. At the end, the performance, it should speak for itself. Gas is speaking for itself because the cost to exploit and the cost to put a combined cycle today is much cheaper than other resources. But bringing it, it may take 10, 20, 30 years of investment.
Yeah, I
right.
would just, one small amendment, which is I would go back to my PV example. The question about what kind of PV industry we're going to build in the state of Arizona is only in part a question about the PV technology and its price and our ability to build a panel, right? Because a whole lot of other things go into the question of whether you're going to build out a whole lot of distributed rooftop or whether you're going to build out a whole bunch of PV as an industrial scale, right? Or whether you're going to build community scale, which is sort of industrial scale, but it's owned by communities in a sort of sharing partnership model, right? Which gets you a bunch of the advantages of scale and manageability on the grid, but also the idea that you're sharing the revenue space with the community and the customers rather than just having it be something, a utility-owned asset. So the policy is still important in terms of understanding how technologies develop out even in well-established sorts of markets.
And that gets me to an important distinction, I think. When you talk about innovation and when you talk about technology policy, it seems like there's two spaces. On one hand, you have the space where technology is being invented in a lab. Something cool is happening. A new invention gets invented. Ideally, you'd like to have a market or a policy space that supports cool inventions getting invented. And then you have the question of, well, once you've got your cool invention, how do you get it to market? How do you get it across that valley of death? Are there policies that can ease that passage? In the landscape that we're in right now, which is more important? Or lay out what policies are needed for both. Do we need policies to drive important breakthrough technologies in a lab? Do we need policies to get what's already been invented out to market, to make it affordable, to scale it up? Can you speak to those distinctions? And if you have a preference on either side.
For us,
for the biofuel space?
For the biofuel space, I mean, the policies are there, and I think our bigger hindrance is getting it out of the lab, and so we're having more of the hurdle at the regulatory side of things and trying to work in that space to get the different feedstocks approved. Last week EPA approved 2 new feedstocks, but we still have 30 that are being reviewed, and we definitely support EPA going through the process to make sure that we do recognize as an alternative fuel, but that's kind of where we're having the problems in terms of driving the innovation that we've already created in the labs forward and getting it into the marketplace. It'll be ready to go in the marketplace. We just need that's where we need the policy to catch up with the technology.
Would you?
I think, first of all, on when you look at biofuels, PV, we are an equal opportunity technology lover. We love all technologies. So it's nuclear, it's PV, it's biofuel. What we want is which one can provide the most reliable, most affordable, safe, and clean electricity. From a policy point of view, you can look at a number of policies, but the one I think which the previous panel actually addressed, if we see distributed resources, combined heat and power because of low cost of natural gas, PV, fuel cell, if you see this, the penetration rate increasing, what is the role of the distribution wires? They provide 2 very important roles. Backup, try to run your home just only on PV, and try to start your air conditioner, see if that starts off the PV inverter. But another huge role it provides is startup. If you don't have a utility connection, you don't have a big source to start your refrigerator, to start your air conditioner. See, there's a backup that is provided by the grid, so if the PV is not there, if the wind is not there, you have backup power. And a startup, it allows you to start up your large loads, your air conditioners. What's the value of that? How do you provide the value of that grid, and what does the role of the grid becomes? It becomes a 2-way interactive network. So I think the policy front in that area, and there are at EPRI, we have an advisory council. We have 10 NARUC-appointed commissioners. We are indebted to them because we get absolutely great knowledge from them on what type of information does technologists have to provide to policymakers so they can make the most effective policy. So I think it is understood that what the role of distribution utilities will be in the future is something that is being questioned. And I think once we clearly understand what the value of that is, a policy construct will evolve in the future.
Yeah, I think that's a really interesting point. I think one of the things that I've learned at this conference, one of the things that's been reinforced a lot at this conference is my conviction that none of the so-called markets that we're operating in the energy space are actually markets. That is, they're not free markets in the sense of the kind of markets that we've seen in other spaces, right? Which makes, for example, translating lessons from the semiconductor industry or the software industry in the U.S. really problematic at times. And so, for example, the Valley of Death language was all invented around thinking about semiconductors and software and really the computer industry. And so, you know, it's not that it doesn't, it's not that that kind of space doesn't exist in the energy innovation space, but the opportunities for getting over it are quite different. And because these are not free markets, I mean, think particularly about the electricity space, but in terms of many of these are regulated monopolies. You know, it's a different ballgame in which policy is there from the outset, and those policies really constrain the ability of utilities to innovate. So one of the things that we're seeing actually in the energy markets as a result is that a lot of people are trying to focus on technologies, particularly if you're looking at the Silicon Valley investment space. They're trying to focus on technologies that you don't have to sell to utilities and you don't have to sell to the big three. Right? If you can sell to an end user customer, right? So a manufacturing company or a household or, you know, anybody who's using energy, right? You've got a much better business model right from the outset because those entities are not regulated in terms of what they can and cannot buy. And they're not regulated in terms of sort of the space, the sort of systems that they have to maintain and operate. I think that creates problems. That creates a very different kind of valley of death in which you don't get a lot of innovation and a lot of investment in these areas like smart grid, where you really have to have these regulated entities as major players in moving forwards in order to make innovation happen.
So it's less a valley of death and more a difficult, twisty, turny path where you're blocked in every turn by an obstreperous policy that's already there, potentially.
Yeah, and it could be, you know, some of these are utility policies, so and some of them are regulator policies, and some of them could be either. So if we're looking at community solar in Arizona, we have one example that's been put together by the town of Marana. They got Tucson Electric Power to agree to let them do virtual metering as an experiment. But basically neither the utilities writ large in the state nor the regulator have said that virtual net metering is a good thing and that we're going to enforce it, and we're going to either allow it if it's the utility, or we're going to require it if it's the regulator, right? So it's these policies are all over the place, and I mean, it's one of the spaces that actually allows for, I think, optimism, is that there are a lot of opportunities for innovation here on the policy side, but you have to get big institutions that are comfortable in the ways that they're doing things, that know how to do what they do really, really well, and don't have a lot of experience in doing things in alternative ways, to think outside the box, and it's a tough challenge, organizationally.
Arshad and Erick, I want to get you to tell us a little bit, you know, both of you said the problem is not having breakthroughs in labs. The problem is not coming up with this exciting technology. The problem is more how do you get it out there? If not the valley of death, how do you get it, you know, through this passage? I'm wondering if you can talk a little bit about, you know, what are some of these newest and most cutting-edge technologies that we're not seeing right now in the electricity and in biofuel space?
Well, I think that some of the newest technologies, we're seeing it right in front of us. We just haven't used them. I think I use this, could be any smartphone, by the way. It's not Apple's advertisement. It could be your Android. Right now, if you want to control your air conditioner, I just did mine. You have to install you go to Home Depot, go to Lowe's, see the number of controllable thermostats you can buy. You can buy quite a few. Costs you $200, $300. And then if you think you're smart enough and you don't need an electrician, in most cases, sometimes it will be better you have one. You hook it up, that's another $100. And with $400, you can control your thermostat from somewhere around the world. It actually is beneficial to do that. Because you can, when you're going away from home, you do that anytime, and you can reduce your bill. But the innovation is not that. The innovation is if you went to Las Vegas this February, the CES, the Consumer Electronics Show, we sold 100 billion Wi-Fi chips last year. Wi-Fi chips are becoming pennies. So you will have appliances that have embedded Wi-Fi chips, and you download the app. And when you download the app, and it's free, that $500 is going to be free in some years' time. We will be managing our energy in a way that we have never done that before. And if you're a distribution utility, or if you are a PJM even, you will have now variability and uncertainty on how load is managed, on top of the variability on the wind and solar. So we do need the smart system to balance load and generation, because I think we're within not even a decade. The amount of Wi-Fi enabled appliances and the innovation that's happening in this space will allow consumers to engage with their appliances in ways that we are just thinking now. And that, I think, could be a near-term innovation that could surprise us if we are not ready.
And for us, we have companies that are working on renewable plastics, renewable chemicals, and I guess for them, like, one of the hindrances is they don't qualify for any of the tax incentives that are currently out there for producers of renewable biomass. And I think just kind of, moving that forward with all the uncertainty that comes from the Hill these days, it's trying to work with them to get them into the tax system so they can secure the investment and the money that's needed for the high startup costs. And I think that's just one of the bigger policy hurdles right now. And kind of when you're saying that there is no free market with energy, there's a lot of people on the Hill that do feel like there is a free market that's out there. And so when you try and work with them to get these sort of incentives to move these technologies forward, they just are adamantly opposed because they don't think there should be any incentives, even though every energy that's out there has some sort of incentive behind it. And so that's where some of our companies are behind the curve compared to some of the more established policies, people that can benefit from the established policies.
Are there any specific proposals right now, either on the Hill or even just in think tanks, that could help change this picture? I know Senator Coons is working on a bill. Are there any specific policies or policies that you'd like to see?
On the tax side, I don't think they've been reintroduced this Congress, but Senator Stabenow had a bill last fall that would be very useful in terms of the renewable chemical side. Senator Coons is somebody that we've been working closely with in terms of helping to get that up and reintroduced here, and on the House side with Pasquarelli. So those bills will be put forward again, but I think right now our understanding is Ways and Means, they are telling their members not to sign on or introduce any tax bill until they can establish their framework for a broader tax reform. And the possibility of that actually happening here this year is very unlikely, but it's making it harder for us to get champions right now. And so hopefully Congress will start working itself out here after the sequester goes in, and we can kind of get a little more direction. But that's where we're at right now.
Are there policies, can you talk about the difference between policies like loan guarantees, stimulus grants, versus policies that create new models for financing, or policies that create markets? Which do you need more? Which is more helpful? Which does energy technology need more?
I'll give you an example. I see over there Mr. Terry Boston sitting there from PJM. So policy doesn't just come from Congress and Senate. It also, market policies are important. If you create a clear market signal, then the market will respond, and you have the resources that can provide reliable and affordable electricity will win. And it's actually, I would say, U.S. is leading far ahead than Europe or any other country. If you look at the Northeast, PJM, New England ISO, the capacity market, The amount of demand response that has bid as a resource in the capacity market is in the tens of gigawatts, Terry? 16 gigawatt. Just think about it. If you guys are on the electricity industry, if you have the history, go back 7, 8, 10 years ago. Just 10 years is not a long term in a 140-year industry. How much demand response did we have in the system? So we have considerably changed that dynamics, opened up a new resource, created a market because there was effective market policy. So policy is needed in all frontier, I'm sure, to enable technology, but speaking from a technology point of view, I think a clear, effective market signal did promote and incentivized demand response technology, energy storage technology to move forward.
Clark, I wonder also, you talked about how the Valley of Death language and idea came from the IT sector. Are there other models in other technology sectors that would work for advancing energy technology? As you look, that have been effective in helping promote IT or health technology or elsewhere that would be effective in the energy space?
I think that's one of the areas where we need to put some real inquiry into place. We've basically done innovation policy in this country on the backs of the success of HP, Microsoft, and Genentech. Right? From the early 1980s, the idea that you take scientific research, you capitalize it in startups through venture capital, you sell those companies to established companies. It would be worth looking at the pharmaceutical space, because at least there is in the way that innovation happens, you have sort of the major companies and you have this startup environment, which makes it more like, in some sense, the energy space. But I think the big difference, and it's not so different now in terms of how computer systems operate, but the big difference here is these existing systems, right? So the grid, or the systems that we have for taking liquid fuels out of the ground, refining them, distributing them, to a highly standardized form of a vehicle or engine that then consumes them. These are enormous systems, and so we're not really talking, there's a lot of individual technology innovation that can take place in them, but what we're really talking about, if we're talking about sort of creating a sustainable energy future for the U.S., for the planet, we're talking about changing these systems bottom to top. And so we need something that's really a kind of model for complex systems innovation rather than a model for new product innovation. And it's not that new products, again, let me reiterate, new products are going to be extremely important to carrying out that systems innovation, but at some point you have to think about the system scale change as an innovation problem. And these systems, historians have now made this deeply clear about the electricity grids, and it's equally true for the fuel system. These systems are integrated systems, they're technology platforms, but they are also social systems, they're political economies. They are integrated systems that cut across every aspect of human affairs. And so changing those systems really is a different kind of innovation problem than simply creating new technologies.
And is a lot of that going to happen at the state level? At the sort of state and utility level, or the federal level? Where do you start that? Where is that conversation gaining the most traction?
Well, I think that what we saw in the last panel is that in some states, and this is a great tradition of America, the fact that we have historically regulated things at the state level, tried to, means that at least for the electricity sector, we're seeing some experimentation happening in the different states as different laboratories. But it's, you know, the fuel system is a more global problem. It may be less of a global problem if Pickens is right and we become America, you know, American oil and gas. But these, you know, that even so, there will be dimensions of that problem that are global dimensions of the problem, because you have, you know, the automobile manufacturers are making vehicles and selling them all over the globe, and so the cross-scale dimensions of these problems make them hard. You know, if you really want to do the kind of demand response kinds of technologies, or the or policies, if you want to do the kind of electricity moving that, for example, Germany is envisioning around their renewable grid, and how to make that work, in other words, moving power very long distances, then, you know, you're back to thinking about the three grids in the United States and how they connect to one another, the degree to which they connect to one another. You know, so I think there's lots of places to start, and some of the theory that's out there around sort of complex systems innovation suggests this, right? There are lots of, you can start almost anywhere, but ultimately the innovation has to encompass the full scale and scope of the system in question if it's to be transformative.
I want to also ask about fossil fuels. You know, as you meant, we've talked about fracking. Fracking and also ultra deep water drilling are two areas where we've seen industry, you know, have tremendous technology breakthroughs with some potential unintended consequences. What happens there? What happens when you have tremendous advances in ultra deep water drilling and great demand for that oil, when you have advances in fracking? What needs to happen in the technology space, and is it happening?
I think it's we are at the early stages of looking at those technology plays. I think even the shale gas resource is very, very new. If you talk with the people who are the producers, the technology still, I would say, the actual production technology 5 years from now, you may be seeing 30–40% gain on how much they're getting. But it actually opens up a very new look into how many different ways we can be using gas. If you're looking at prices, you're seeing gas to plastics. You know, we consume, I don't know how much plastics in the world, a whole lot of plastics. But plastics is just one of the things. We are using crude to make plastics. We may be using natural gas to make plastics. We may be using plastics to make a lot of other products, and it could bring back the industrial manufacturing back into U.S. And then that is a tremendous opportunity to look at these resources, not just on the power sector, but also in other sectors, because it is a change, and that change technology with enabling policy and innovation. And we forget some of the shale, as you were saying, early 80s, the work that was being done. Even in the 70s, the DOE had a huge effort on making where shale is today. So no, those are absolutely needed.
Well, I think on the plastic side of things, and with oil and gas, I mean, we've had an increase in production this past year domestically, yet we still have our oil and gas prices going up. I mean, the world demand is far outpacing what any gains that we're going to make, and, you know, we should keep making those explorations and try and be optimistic, but we're going to have to find alternatives. And so, you know, back to the policy side, that is where it is helpful to have these incentives looking at the bioplastics and looking at, you know, how we can derive plastics from other materials, so we're not, you know, taking fuel out of our cars to try and bottle our Coke, and we can find other ways to do it. So, you know, that's...
Let me pick up the other side of your question, which has to do with the consequences of these innovations. It's an important point, and I think what we see, and this is true in every sector, right, is that these disruptive innovations are in many ways disruptive innovations, and it's worth keeping in mind and sort of thinking ahead about where those disruptions are occurring and what those might mean. Let me give you an example again from solar. Right now, Solar City is selling solar PV systems for rooftops in Arizona, not selling, leasing, at about 2/3 the price of electricity from the utility. We are well beyond grid parity. What that means is a complete unknown at this point in terms of the ability, particularly of utilities, to continue to operate on existing business models. So we've launched a new Center for the Utility of the Future, really to probe that question. I don't know whether we'll be fast enough or not. Installations are going in very rapidly. Some of our communities in the state have 12% rooftops have solar energy on them now. Ironically, others have very low amounts. The difference has to do with social networking. So social networking turns out to be a huge market multiplier in this space. But the challenge is to really understand that, it's not that we have a regulated monopoly in Arizona because we like regulated monopolies. We have a regulated monopoly in Arizona because the state has, over the decades, pursued very consistent public good policies, right? For particular reasons that had to do with the reliability and security and access to relatively low-cost electricity, right? You were talking earlier about the various kinds of things that solar cannot do. One of the things that you start to think about what is the future of the utility under conditions in which rooftop solar is at grid parity, and all of a sudden your utilities are shedding a lot of load. You add on top of that another policy innovation that we pursued in Arizona, which is we have a 33% energy efficiency standard on top of our 15% renewable energy standard. Right? So now the major sort of equation that governs utility revenues, right? The rate equation, in which building new power plants is a primary mechanism through which they grow their rate base and therefore they grow their shareholder value, right? Because these are publicly owned stock companies, right? Is very hard to meet. Right? The expectation is that we won't need a new power plant in Arizona until well beyond 2030. Right? So this becomes a real challenge as you're shedding this sort of load and at the same time expecting these companies to back this up in the case that all of this sort of shadow load, ironically, much of it, they don't even know how much shadow load is out there on their grid. In other words, by shadow load, I mean load that is currently being taken care of by solar systems, but that if dense clouds came over, would have to come back on their grid, right? So that goes to that information problem that we were talking about earlier, right? So there's all kinds of challenges for utilities in this context in terms of maintaining the viability of our ability to serve these very serious public goods, right? So one of those is to provide electricity to people who can't afford to put solar on their own roof or maybe don't own their own home. Right? So one of the things that our renewable portfolio standards we think about is sort of social impact question. Our renewable portfolio standard in Arizona, which in many ways is a very progressive one, it has a 30% distributed generation carve-out, so forth. The way it was structured, it functions exactly like a reverse Robin Hood scheme. The average ratepayer pays in chunks of money into a pot of money, which we have the data to show this. The wealthiest zip codes in the Phoenix area then scoop up that money, put solar on their rooftop, take themselves a big chunk of their electricity demand off the grid, benefit dramatically from that, leaving a poorer community to pay for the sort of average rate payments. So,
I want to move to some of the audience questions. I think this is probably a little more aimed for Arshad and Erick. It says, there seems to be a lack of trust between innovators and policymakers. How can this be improved?
Oh, I actually think, no, there is. I think there is a good bit of trust between innovators and policymakers. Can it be better? Yes, it can be better. When you look at policymaker in the context of not just Public Utility Commission for markets, I think some of the work that has happened has enabled us. And at the end of the day, if you're in the shoes of a Public Utility Commission, you're looking at customers, you're looking at affordability, you're looking at reliability, you're not looking at cool technologies. So they have a tough choice to make sure that at the end we are looking from a customer point of view. Are we doing things that will ensure that they're not out of power for 14 days? Are we doing things to make sure that electricity will continue to be an affordable source? So I actually feel that, can we do better? Absolutely, we can do better.
Yeah, I don't think it's a lack of trust. I mean, having just came off the Hill, I think for the policymakers and for the staff, it's just they have such a finite amount of time to handle the certain issues. And so for me, energy was just one of my issues in my portfolio. I had to deal with ag, environment, immigration, trade, and then all the little sub-issues that flare up all the time and distract your boss over the course of the week. And so for them to really delve into these new and emerging energy technologies that are happening in their state and, to fully learn about, to find the incentives to help push that through, it's just, they're very taxed for their time. And so, I mean, for the innovators, where they can, come to DC, invite the members to their facility and get them to see it firsthand that it is creating these jobs and new marketplaces back home. And I think that will help drive it forward. But I don't think it's a mistrust, just lack of time.
Another question from the audience. How would Senator Kuhn's master limited partnership, which we talked about, affect renewable energy? And if you could just in a nutshell describe what it would do.
And I haven't had a chance to talk to them here this year on this one. It's to try and bring everything kind of onto a parity, to give everybody kind of equal footing in terms of taking advantage of the tax code, I guess, would be the quickest way to do it.
And so how would it affect renewable energy?
It would put them on the same footing as a lot of the more traditional sources of fuels. Excuse me.
I think the central issue that it's intended, although I don't know the legislation in detail, but I think the central issue that it's intended to impact is the cost of financing. And this is significant. So we have a former fairly high-level official from BP who now works at ASU, and he's constantly surprised with his discussions in the sort of innovative technology space in energy at how much it costs people to borrow money. Because it didn't cost BP that much to borrow money. Sometimes 300 or 400 basis points of difference. And that's a real limitation in terms of the ability of these innovative approaches to energy to get financing and to support it. I mean, and it's not just an issue of costs of financing, although that's a big piece of it, but it also has to do with the sort of complexity of the arrangements that have to be made in order to get around those kinds of financing requirements. So in Arizona, at the moment, we have one bank that is systematically engaged in financing projects in the solar space. That bank could probably take more onto their balance sheet than they currently do. And they've taken the time to build up the capacity in-house to do these kinds of deals. But they're different deals than banks usually do, and other banks have simply proven thus far at least not interested in following their lead and making these kinds of investments. So another thing that this would do is it would create for the renewable space, I suspect, a familiar model in which investors can put money on the table. At the same time, I think we're seeing, here's another interesting case of sort of regulatory, it's not quite barrier, but there is some challenge to it. So we're seeing these innovative crowdsourcing models begin to emerge in some of these spaces, solar in particular. And I tried to actually invest in one of them the other day. So it turns out you can only do this if you're if you meet some class of SEC approved investor. So you either work in the investment industry or you have enough money that you can lose some, and it's really, they feel it's your own fault. So these are pretty high limits. So you either have to have a net worth of $1 million or you have to have an annual income of $200,000. Now, state regulators can exempt this, and so there are sort of 6 states at the moment for which these crowdsourced models are sort of exempt, and anybody can invest. So here's the difference, right? Banks are looking for 15%-ish return on investment on projects they're willing to loan at. Individual investors, retirees, are looking at 1%, 2% maybe on treasury bonds, right? So the data suggests that these solar projects are as secure as treasury bonds, and this isn't just any data, this is from the banks themselves that are investing in these projects. The repayment rates are very, very good for these kind of projects. So these crowdsourced models are offering somewhere in the middle, right? 5 to 6%, which vis-a-vis treasury bonds would be great to be able to put some of your retirement investments in these kinds of projects. But if you can't meet these limits that the SEC has put together, then in most parts of the country at the moment, you can't invest in these kind of products.
Another question from the audience. What is the panel's opinion of regulations' impact on research and commercialization of fuel-saving autonomous vehicles, such as the Google Stanford vehicle, Volvos, or Toyotas?
I think those are all, if you look at where we are on plug-in hybrid or electric vehicle, and if you look at what Google is doing and others are doing, at the end of the day, the performance, is it going to make the road transportation system more safe? The answer is yes. I'm sure those technologies will penetrate. I mean, it's equal opportunity. You look at technology, you look at the performance. Yes, you need you need policy, you need to spur the technology, but at the end of the day, if the technology doesn't stand for itself, and in many cases some of the technologies haven't. We heard about Germany, and if you look at what's happening in Germany, what's happening in Spain, the technologies are still trying to stand up without subsidy. And we as technologies have to continue to work to make sure that at the end of the day, and the day could be 20, 30 years long, these technologies will be self-sufficient.
Another question, why are we being reactive on this policy debate? Aren't there proactive policies we could adopt to accelerate our transition to clean tech? How about U.S. government spending policies?
I certainly hope that I'm trying to be proactive, right? In the sense that I think that that there's a real need for policy innovation in this space, and we really have to look at what kinds of policies work. Let's use the fact that we have 50 states that are being laboratories for different kinds of innovation here. Let's evaluate what works across those different policy domains. And let's use that as a basis for moving forward. But I think, an interesting sort of point is, and it goes to the questions, the government spending practices, right? So, but not quite in the way the questioner asked. I suspect that related to questions like DoD, Department of Homeland Security, and others, and what they buy, right? So, and those are obviously important places where potential innovation can be made. But if you look at the Department of Energy, for example, we spend here in the Department of Energy several $billions a year on a couple of different things. One is energy technology innovation, both in terms of research and in terms of sort of project development, creating pilot tests, pilot programs, and so forth. But also on training innovators, right? Training people who will go out and innovate in the science and technology sector. DOE spends very little, if anything at all, on either research or training innovators in the energy policy space, right? It's a question of how we sort of are thinking about this innovation problem, and to the extent that we think that it is solely a problem for the technology space, we will continue to get the kinds of policies, spending policies, in our R&D agencies that we've gotten in the past. But if we broaden our horizons and recognize, for example, that demand-side management may entail significant consumer behavior change that's required in order to become full active participants in these kinds of activities. I heard the last panel talking about real-time pricing, and I'm thinking, wow, I'm going to have to become a much more sophisticated consumer of electricity if I'm going to have to deal with real-time pricing of electricity coming into my house, right? So if we have to think about social innovation, if we have to think about financial innovation, if we have to think about business model innovation, if we have to think about economic systems innovation, if we have to think about policy innovation as part of the technology innovation project, then we need to think about investing in innovators who can think in those spaces at the same time.
Last question. We're running out of time. I think this is a great question. Many people are critical of anything the government does. What is the simplest thing it can do to improve policy making in the energy space?
Do you want us to focus on the simplest or the can-do part?
You know, there's a lot of things that can't get through the hill right now, but I think it's interesting to think about, okay, in a dream world where you could have, you know, the most ideal change or the most ideal energy policy, sort of let's call this a dream scenario. The simplest thing the government can do to improve policy making in the energy space, short of reconfiguring the House of Representatives.
Clarity and clear. Clear policy.
That's exactly what I was going to say.
Whatever it is.
Whatever it is, right. 20 years, but guaranteed for the next 20 years. Right? A plan for what we want to, what the policy targets are for a clear plan.
Okay. All right. Well, we've reached the end of our time. Please join me in thanking our panelists. This has been great.